we will now see some properties of getting the transpose of matrices. So, for example, if we get the transpose of a matrix, we actually get the original matrix back. Why? So, as you might recall, getting the transpose of a matrix would turn it into AJI, right? And so now, if we get the transpose of AJI, we would get AIJ back, which is the same thing as we had at the beginning. So just flipping IJ once and then flipping it again, we just get IJ back, which is just the original matrix. If you don't believe me, let's do an example. So we had, let's say, just this matrix. This is equal to A. And now let's get the transpose of it. So to get the transpose of this, we have A11 and A21. And so if we get the transpose, we still A11. So whatever was in A11 is still in A11. But now A21 becomes A12. So A12 is right here, next to the 0 instead of underneath. So now if we take the transpose of this, so we're basically getting the transpose again. Now we have something in A11, and this is still in A11. So the 0 is still in the same place. But whatever is now in A12, it's going to be in A21 in this next transpose. So it's 0, 1. And oh surprise, this is exactly the same thing. And that always happens, doesn't matter the size, if it's a square, a rectangle, whatever, the transpose of the transpose is always going to give you the original matrix. Now, our next property is that multiplying the transpose of a matrix times a scalar is the same thing as, multiplying I had it wrong. So multiplying a matrix times a scalar and getting the transpose of that is the same thing as getting the transpose of the matrix and then multiplying by the scalar. So why is this true? If we represent the matrix A with this term right here, which I explained what it means in one of the previous videos, so I won't do it again, and we multiply this times K, we know that multiplying times a scalar just multiplies each one of the entries times that scalar, and this will be represented as K times AIJ, because every entry, and this represents every entry, is just multiplied times K. And now if we were to get the transpose of this, we would get K times AJI, because actually you don't have a transpose of a number, it's just the number. So the only thing you get kind of the transpose of is of the matrix, and the entries change from J to I. So now, that is for the left side. Now let's look at the right side. So the right side says that first we will get the transpose of this. So if A is equal to IJ, then the transpose of this will equal AJI. And now after this we will multiply times K. So when we multiply a matrix times K, we get that all its entries are multiplied times K, and we represent it like so. And we get that they are the same thing. Very well. Our next property and last is very interesting. So if you were to add two matrices together and then get the transpose of them, it's going to be the same thing as getting the transpose of each one of the matrix and then adding them. Why does this happen? Well, if we were to represent the matrix A with this term right here, and the matrix B in a similar manner, but with B instead of A, of course, and we were to add them, well, the resulting matrix will have each one of its entries as the addition of the two corresponding entries in this matrix. So here, as you may recall, whatever is inside the brackets represents kind of each one of the entries, but only one entry itself. And so this tells you that each entry is going to be the addition of the corresponding entries of A and B. And so if we get the transpose of this, well, it's the same thing as just transposing this into whatever other value it is, which is equal to transposing the values independently. So we get that the transpose of this resulting matrix of the addition is just the transpose of this, and it would be equal to this. And now if we were to do it differently and do it like in the right hand side, we would take the transpose of A first, and so that's equal to AJI, and then the transpose of B, which is equal to BJI, and then we would add these two, and by adding these two we get AJI plus BJI, which is equal to what we got before, so that holds.